Eric Burgess here, and we've been given the following equation. Now, this can scare people because it's got fractions, and you may be a little rusty with the fractions, but let's just go ahead and tackle this thing one step at a time. So the first thing we want to do is we want to get all the x's on one side and all the other stuff on another side, and this is the advantage of we can combine things with x's. So we look at this and we say, okay, well, there's an x right here term, and there's a term with an x here, so it'd be easier to move this term that way. So that's what we're going to do. So this is a positive 1/5, and so what I'm going to do is I'm simply going to do a negative 1/5 to both sides. So I add on a negative 1/5 here, 1/5 x, and then the 7/4 was positive plus 1/5 x minus 3/2. So that's the first side, and the other side is 4/5. And because of equality, since we have to be equal, I have to do the same thing to this side. So minus 1/5. So x. And this is an x as well. So these two 1/5s, they combine to make 0. So they essentially just go away. And on one side, we're left with 7/4 minus 3/2. And on the other side, we have 4/5 x minus 1/5 x. 4/5 x minus 1/5 x. Now looking at this, we could see that the fractions with the x's have the same denominator. And what makes that really nice is we can just combine them straight up. So the one side's going to stay as 7/4 minus 3/2. And this side can be combined. When we add or subtract fractions, the denominator stays the same, and it also has to match. And then we have 4 minus 1, that's just 3. So we have 3/5 x. Now, that takes care of the one side, but the other side, they still don't have matching denominators. And so here, what I'm going to do is I'm going to get rid of all the fractions, because at this point, is a good spot to just sort of get rid of all of them. We could actually do this on step 1 as well. But basically what we're going to do is we're going to multiply by a number who can get rid of all the denominators. So we need a number that has 4 as a factor, 2 as a factor, and 5 as a factor. Now 4 is really just 2 times 2, right? So 4 is 2 times 2. So that means that this 2 has already been included in the 4. So we actually don't need to worry about it. So we only need the 2's. We need 2 of them in order to include the 4, and we at least need 1 for the 2. So we need to have 2 2's and a 5. This number gives us 4 times 5, that's 20. So this means that if we multiply this equation by the number 20, then we will get rid of all the fractions, because 20 can simplify with 4. 20 can simplify with 2, and 20 can simplify with 5. And what we did is we just made a list sort of all the factors. And since 2 is already in 4, we didn't have to worry about it. But 4 required 2 2's. So you can use this trick whenever you're dealing with fractions. So what we're going to do is we're going to multiply one side times 20. And because of equality, we have to do it to the other side to be equal. Multiply this side by 20. So when we multiply the 20 by this side, it's going to look like this. It's going to look like 20 times 7/4 minus 20 times 3/2, right? By distribution, it would go like this. In the future, I may just do this in one step, but for now, I'm going to show every step explicitly. And then this is 20 times 3/5 x. All right. So the 4 and the 20 can simplify to 1 and 5, and 5 times 7 is 35. The 2 and the 20 can simplify to 1 and 10, and 10 times 3 is negative 30. Well, there's a minus sign here that I'm accounting for. Now, when I say simplify, I mean we're really dividing the 20 by a factor of 4. If I were to rewrite just this first bit here, it'd be like 20 times 7/4. And we notice that 20 is 5 times 4 times 7. And 4 is just 4. So the 4 simplify, and we're left with 5 times 7. And whenever something simplifies to 1, anything divided by 1, because 1's on the bottom, is itself. And that's why we can simplify and sort of do these kinds of simplifications. So, okay, we get this side. On this side, the 5 simplifies to 1 because we divide by 5. We divide the 20 by 5. 20 divided by 5, that gives us 4. And 4 times 3 is 12x. So now they're just straight up integers, much easier to deal with. So 35 minus 30, that's just 5, equals 12x. And now to undo the multiplication, we simply divide. So we divide by 12 to both sides. And we get 5 over 12 is equal to x. And this is our solution. Now we could check this solution. You could plug it in by hand and do it that way. I'm going to go ahead and just check it with a calculator. So we want to make sure that this side is equal to this side. So let's see here. If we plug in 5/12 for x, what do we get? So this calculator can actually type fractions. So I'm going to go ahead and turn it on. If your calculator can, I highly recommend using it. So in this calculator, you hit the green key and then F1 and you can type fractions. So I'm going to go ahead and type this. We have 7 over 4 plus, and then we have another fraction. So I'm going to go ahead and just type that. You could type divisions with parentheses if your calculator doesn't support this. But this is 1/5. And then wherever you see an X, just put parentheses and put whatever x is in the middle. So x is 5/12. So this is a fraction. So I'm going to type another fraction. 5 over 12. And if you always substitute x with parentheses, you'll avoid common mistakes. Minus, and then another fraction. 3 over 2. And that's it. Because we're only plugging in this side and we want to see what we get. So when we do this side, we get 1/3. So let's go ahead, let's try the other side. So the other side is 4/5. So we're going to type in our 4 over 5. And then there's an x, so we put a parenthesis. And x is 5/12 according to what we have. So we type in 5/12. And we put another closed parentheses. And we hit enter. And we get 1/3 again. So we went ahead and we checked our work, this time with the calculator to kind of just speed it up. And we get the exact same result. Now, of course, you could go through and do this by hand. It's just a lot more fraction manipulations. So if you're good with fractions, this should be a piece of cake. But I know it can be a little confusing at first, remembering all your fraction rules. So just remember, adding and subtracting, denominators must be the same. And you have to get them to be the same if you're going to do it. And when you're multiplying, you just multiply straight across. When you're dividing, you have to multiply by the reciprocal. So there's like a super, super fast revision of the fraction rules. If you have any questions, let me know, subscribe, and we'll catch you in the next problem.